All right, this is section 7-7 called Writing Linear Equations. Example 1 here on page 397 says write an equation in slope-intercept form for each line. It tells you the slope is 4, the y-intercept is -8. So in this equation, remember, all we have to do here is fill in what m is. Remember, m is the slope. And then you write y and x in there, and then you say plus b. Well, b is the y-intercept, -8. Instead of writing plus -8, just write -8. There you go. That is A. Part B says slope is 0 and y-intercept is 5. So again, using this slope-intercept form, m becomes 0 and b becomes the y-intercept. Now in this case, if we were simplifying, we would just write y equals 5. All right. So what happens is, because of this 0x, remember these are multiplying. What is 0 times x? Well, 0 times anything is 0. So you get 0 plus 5, which is just 5. So if you were simplifying it, it would be this. That doesn't make the slope change just because it's not in the equation, but the slope would be 0, which it says up here, because of 0x. All right, example 2 on the bottom there says write an equation in slope-intercept form for the line graphed. So this is the graph that they have. You can see that in your book. Remember what we need. We need m and b, slope and y-intercept. Well, in this case, here is the y-axis, right? This line here is the y-axis, and it's crossing, this line is crossing the y-axis at 1. So that means b is 1 because that is the y-intercept. And then the slope, remember, is rise over run. So we're going to do that part next. Just going from one point to the next, I would go down 3, right 1. The rise is -3, the run is 1. So that gives me the slope of just saying -3, right, if you simplified it. So let's use our y equals mx plus b. M is -3, and b is +1. Y equals -3x plus 1 is the answer. All right, example 3 says, this is on page 398, on a summer day, the temperature at altitude 0 meters, or sea level, is 30 degrees Celsius. The temperature decreases 2 degrees Celsius for every 305 meters increase in altitude. Predict the temperature for an altitude of 2,000 meters. Now, the first thing I'll show you here is there's actually a typo in your book. It has, if you look at the table, it has the altitude as y. So change that to x. And then it has the temperature in degrees Celsius as x, if you're looking at the table. So let's change that to y. All right, so we're going to do a couple things here. We're making a prediction. And so the first thing we want to do is figure out our equation, right? So we're going to use y equals mx plus b. Now, as we look at this, it's giving us a couple things, right? It's telling us what m is, right? We've got to figure out the rise and the run. Remember that m, rise and run, is the same as delta y over delta x. Same thing. Change in the y's versus the change in the x's. So if you're looking at the y's, remember the typo in the book, the y's are the temperature. What is happening, and they've given you 3 points. We only need 2. So just pick the first 2 points, 0, 30, and 305, 28. So how are the y's changing? That's the temperature. From 30 to 28, the y's are changing by going down. How are the x's changing? The altitude. From 0 to 305, that is an increase of 305. So, you know, the book is, they have that same fraction, but notice that they actually change it to decimal form. I'm just going to leave it in fraction form because it actually is simplified. So that becomes x. Or sorry, that becomes m. Staying in my formula here, if you can tell. And then I've got to figure out what b is. Well, remember that b is the y-intercept. Well, the one thing I'd like to, point out here is that the y-intercept, anywhere here on the y-axis, where the line crosses through the y-axis is the y-intercept. Well, what I want you to tell me here is, what is x anywhere on this line? All right, what is x? Well, y anywhere on this line is pretty much any number. Y is constantly changing as you move. Y is changing. But what is x everywhere on that line? X is 0. All right, every single point on this line, x is 0. So look back at the table. Where is x 0? Well, the altitude is 0 when the temperature is 30. So what does that make our y-intercept? Our y-intercept is 30 because that's where we found x to be 0. I know that is probably a little bit confusing, but if you look in the book, it shows that as the y-intercept. Right? So that's my equation. Now what I'm doing is substituting, because it tells me to predict the temperature for an altitude of 2,000 meters. Well, altitude is the x's. If you look back at the table, altitude is the x's, so it's saying what is the temperature if the altitude is 2,000 and the altitude is the x's. So what I do now is plug in my 2,000 for x. All right, so everything else stays the same, and then I'm solving this thing for y. Solving it for y. So now I can use my calculator, right? -2 divided by 305. If you do that, you'll get a decimal. Now don't estimate the decimal to what they wrote in the book. Just leave that decimal in your calculator. Remember, it's timesing here, timesing by x, so it's timesing by 2,000. Go ahead and times by 2,000. You'll get another number. Now leave that number in there also, and then add 30 and push equals. And you should get that y equals about positive 16.88, so on and so forth. And as you can see in the book, what they did was they said that's approximately 17. And remember, that's y, so we just found the temperature. So my answer is 17 degrees Celsius, which means at an altitude of 2,000 meters, I predict that the temperature is around positive 17 degrees Celsius. All right, example 4 says, write an equation for the line that passes through these 2 points, -2, 5 and 2, 1. And again, since we're writing an equation, we want to use this y equals mx plus b formula. All right, so we need to find m, and we need to find b. And as you know, we already know how to find m. We can graph this. -2, 5 would be right here. Almost right there. And 2, 1 is here. All right, and so we're graphing this. If we draw that straight line, now here's the deal, right? So we need to find the slope and we need to find the y-intercept. In this case, the slope is pretty simple. We can do rise over run. So we go down 1, 2, 3, 4. So the slope, m, would be -4 over the run, which is 1, 2, 3, 4. So the slope is -1. That's going to go in the equation here. And this equals y. And then we're going to add b. So we got to find the y-intercept. Well, remember, here's the y-axis. And so we're trying to find where this line crosses the y-axis. You guys can tell it kind of looks like it's going through the 3. But keep in mind that our slope is now -1 over 1, right? -4 over 4, same as -1 over 1, which means that it's going down 1, right 1, down 1, right 1. So we're lucky enough that this slope, when you keep going at its simplest version, actually does hit exactly on the y-axis at +3, which makes our b 3. Alright, so our equation for this one, if you simplify it all the way down, they usually like to take that 1 out and they just say -x plus 3. That becomes your equation. But just keep in mind there is a -1 over 1 there in front of the x. And here's example 5. This wants you to use the table of values to write an equation in slope-intercept form. Alright, so we've learned this in the past, but we've been given 4 points here. And how many points do we need for a line? We only need 2. So we're just going to choose 2 of these points, right? And we're going to try to figure out what this equation will end up being. We need to figure out what m is and b is. Now, if you graph those points, you'd be able to figure out the slope by doing rise and run. But I'm just going to show you how we can find the slope by doing this method also, right? Just using the formula. I'm going to go ahead and use the first 2 points, all right? So we're going to call this x1, y1, and we're going to call this x2, y2, all right, for each point. So I'm going to plug these in now. So y2 is -2, then there's a minus sign, and y1 is 6. Plugging in x2 is 5, there's a minus sign, and then x1 is -5. Alright, so if I simplified this, my slope would be -8 over 10, and then obviously I can simplify that to -4/5. Alright, so that's what m is going to equal when I start writing this in my equation. Alright, so we're going to continue this. Now, notice we're solving this by not trying to graph it at all. Right? Graphing, you can easily find the rise and run, and sometimes you can easily, just see where the line crosses the y-axis. But in this case, we're going to solve this a different way. So you can tell that we've already found what m is. So in our equation, we know -4/5. But what happens is, what we're looking for is b. Right? So we don't know b, but we do know 4 different values for x and y, right? First value, second, third, and fourth values. So what we're going to do is we're going to plug in any one of those points. -5, 6, or 5, -2, or 0, -6, or 5, -10. It doesn't matter which ones you choose, because any one of these we're going to plug in and solve it, and we're going to figure out what b is. So in this case, I'm going to use my first points. Now, you could go ahead and choose any one of the other points just to see if it works. It will if you do it correctly. But I can pick any one of these points. So I chose -5, 6. -5 went in for x, and 6 went in for y. And I'm going to solve it. First thing is multiplying. I'm going to put that over 1. Those are multiplying, so notice these will cross cancel. Gives you 1 and 1. So you got -4 times -1 is +4. On the bottom we have 1 times 1. So we now have 6 equals 4, +4, plus b. And I hope you can all tell if we subtract 4 here, we would get 2 equals b. Now, m is -4/5, and b is 2. So I can write my equation now, right? As -4/5 x, and that's a +2 for b. So that's how you solve that. Again, I could have chosen any points for x and y, but m, as I already found out, was -4/5. So I use any one of the points to figure out what b is, and once I find b, I go back and write my equation in slope-intercept form.